All right, hello, we're live. Welcome everyone. Thanks for joining us to this remix edition of our Prisma Meetup Online. We appreciate everyone being here, and we should be in for a treat. My name is Austin Crim. I'm a developer success engineer here at Prisma. I just joined a few months ago, so if you don't recognize me, that would be why. But I'm glad to be here as your host, as well as one of the speakers today talking about Remix. Remix is a new web framework created by the folks who brought us React Router, Ryan Florence and Michael Jackson. And it's kind of been something of a hot topic since its stable release earlier in the year. And personally, I'm really excited about the possibilities of Remix and Prisma together, the developer experience that it'll enable for developers of all backgrounds, varying experiences and roles. So without further ado, let's get into the agenda and get this going. So yeah, I'm gonna lead us off and just give us a brief overview of using Remix and the Prisma data proxy together. Chance Strickland will go next, talking about optimistic UI. Alex Anderson will bring up the rear, chatting about the crazy things we can get into with Remix resource routes. And then we'll also have a raffle at the end of the stream, so be sure to stick around for that. We are raffling 5 tickets to Node Congress today. Node Congress is a conference that's happening just in a few days, discussing Node.js, backend development, full stack web development, all those great things. We have 5 tickets today to give away. We have the link in the YouTube chat, hopefully, and you can throw your name in the hat and we will pick 5 lucky winners at the end of the stream. So be sure to get your name in there before the end to get a chance for one of those 5 tickets. Okay, so there's my big face, and we are going to start off talking about Remix and the Prisma data proxy. So let me just get situated. Looks like we lost my screen for a second. Just bear with me as I get that re-added. So talking about Remix and the Prisma data proxy, the Prisma data proxy is a solution that our company is coming up with to handle what's called the database connection pooling problem. And that's something that happens when you're using a serverless backend that's connecting to a traditional database. Okay, it looks like that's coming through here. Okay, sorry about those technical difficulties, but it looks like we have everything going. All right. Yeah, so I have a really basic Remix app here that I'm going to use as an example of getting started with the Prisma data proxy. Now, as a step back, using Remix and Prisma together, I think is an excellent experience. It has the thoughtful abstractions of Remix that take you from the front end with a React web application, makes it easy to access your server, both for reads and writes. And then the experience we get from Prisma that we know and love with the auto completion and the type safety for managing your data access layer. And one thing that I personally loved about Remix and Prisma both is, as I would consider myself more of a front-end or front-end leaning developer, Remix and Prisma allow me to move comfortably towards more the middle and the back of the stack without getting too far out of my comfort zone, and enable me to build applications that use a database and have the backend logic in a way that's both co-located and that makes sense with my mental model. One great thing about Remix is its strategy that it takes to deployment or deploying an application. So if you look at the Remix docs, the strategy they take is when you initiate a new Prisma project, a new Remix project, it asks you where you're going to deploy your application. And one of the most popular ways is to deploy using a serverless backend. So something like AWS Lambda using Architect, or through Vercel or Netlify, which also use serverless functions under the hood. And serverless is a great developer experience and a great user experience in that you don't have to think about a long-running server and all the configuration that comes with that. You get more efficient usage, all the things that we have appreciated about serverless since it's come to the forefront. But one of the issues you get when you're using a serverless backend with a more traditional database, a relational database, or something of that like, is what's called the connection problem, the connection limit problem. Most traditional relational databases have a limit on how many connections they can have at any one time. For something like PostgreSQL, a popular option, I think the limit's like around 100 or something like that at a time, which may sound like a lot, but when you have a serverless backend that can scale pretty much infinitely, you might run out of those connections at some point. And there are other solutions that have come to the forefront in the past, things like connection pooling, heavy caching, or even horizontally scaling your database infrastructure. And while those can work in some scenarios, I personally don't want to have to think about that kind of infrastructure or doing those kind of DevOps tasks as, like I said, mainly a front-end developer, as I would consider myself. And that's where the Prisma Data Proxy comes into play. And that's where we're going to get into the demo here. So like I mentioned, I have this basic Remix app. Looks like my screen share is getting a little mangled. So I have this basic Remix app that has basically just one or two routes, and it's essentially a note-taking application. So we have a form with a couple inputs where you can get a title and some content, and we just post that to our backend using Remix. So as I mentioned before, this is where Remix's developer experience comes into play, where you have your React component and your reads and your writes all co-located in the same spot, which makes it very easy to manage or easy to think about. We have a loader and an action, which I'm sure we'll talk about more, either in my talk or Chance's. And we're using Prisma in those to save our notes to a Postgres database that I already have set up. I also have a simple load test using case 6, which is a popular Node.js load testing tool that essentially posts to my Remix app using many concurrent requests, simulating maybe a traffic spike if my application got really popular, or maybe if it got retweeted by Kenzie Dodds or something like that, and my application needed to handle a lot of traffic. This is what this simple load test simulates. Now, if I run this load test, where my serverless backend is talking directly to my relational database, let's let that run. Let's see if I can make it easier to read. Looks like the bottom of my screen might be getting cut off. That's interesting.
Hey. So it's gonna look better if instead of sharing the whole screen, you only share one tab or an app.
Okay, thanks, Natalia. I'll go ahead and give that a
Sure.
shot.
I'm not showing my camera. I have almost no bandwidth here, so it's like a voice from the backstage.
Okay, I appreciate that. I'll try and reshare and see if I can get a little bit better quality. Unfortunately, I was wanting to switch back and forth between a few different, between a web browser and the code, but we'll see if we can get this to work. Again, I apologize to the viewers for these technical difficulties. And that looks a little bit better. So there's a lot of output here. Sorry, I was backing up. So I ran my load test that simulated 50 concurrent users trying to post a new note using my application over the period of about 5 or 10 seconds. It's just 50 people trying to post a note continuously. And the important part that we want to look at right here is the failed HTTP requests. And in this scenario, we had about 30%, 32% of our requests fail. And if we checked the logs on, I think I have this deployed to Netlify right now, you would see it's complaining about connection limit. And that makes sense if we because we're having over 100 concurrent connections trying to open at the same time. Now, if you had your application running on a serverless backend and you had a spike in traffic or it got more popular, and this is something that could happen to you if you didn't do anything to mitigate it. Again, this is where things like connection pooling or horizontal database scaling would come into play. But I've already established I don't want to go into the AWS console any more times than I have to. And this is where the Prisma data proxy is trying to step in and provide the service in an easy and low configuration way to go. So now I'm going to quickly take us through setting up the Prisma data proxy through cloud.prisma.io. I'm going to hook it up to our web app, get the proxy going, and rerun the load test and hopefully see some better results. Again, I'm unfortunately having some screen sharing issues. I apologize. It should be the last time I have to do this. Let's see. Nope. All right, we'll see if that'll work. Okay, so we're looking at cloud.prisma.io. I'm going to take us through the flow of setting up the Prisma data proxy for our small application that I just demoed. I have a few apps already out here, but we're going to create a new project, and I'm going to call it Remix Prisma Stream, which I believe is the same name as my repo. I'm going to import an existing repository, like I said, Remix Prisma Stream. And we'll move on. Through here, we have a couple of different options. So it asks if we want to provision a new database, and it gives us the option to either directly provision PlanetScale or MySQL on Heroku straight from here. But like I mentioned, I already have a Postgres database running. So I'm going to use my use my own database and paste in my connection string here. And I'm going to do this off screen so no one gets mad at me. So I'm going to quickly take that off. So what's going on here is I'm giving my plain database connection string to the Prisma data platform. And in return, it's going to give me something else. Let me bring it back. So what it's going to give me in return is a Prisma data proxy URL. And I'm going to use this URL to connect to my database from my application instead of hitting my database, directly. The Prisma data proxy is architected in such a way to be able to handle large amounts of requests without overwhelming your database in production. So, apologize for these technical difficulties. So See if I can get my screen back up. Looks like we're hitting an error that I was not anticipating. Let's try this again. Okay, here we go. That's much better. Okay, so I plug in my database connection URL, and it's giving me back what's called a Prisma data proxy connection URL. And now that I have that in place and copied and pasted off screen, so no one can steal my important test data, I should be able to share my screen again here. Sorry about that. Okay. I've got that going. I've got that pasted. And we are good to go. All right. So I apologize I had to do so much off screen there. But this is the next screen that we get. So I plug in my connection URL. It provisions a data proxy instance on Prisma's infrastructure. It gives me a connection string here that I'm not going to reveal. And this is the string that we're going to use to connect to our application. So I've got that pasted in the correct spot. And now it's let me into the Prisma Data Platform UI. So I've updated my connection string URL over here in Netlify where I have my website deployed. And I've told my serverless backend to, instead of going directly to the database, use the Prisma data proxy instead. And we should be able to handle traffic spikes and more heavy production scale without an issue. So I'm going to make sure I have the correct URL here for my preview deployment, which is using the data proxy. And I do have the correct URL, but I'm getting it in error. Let's make sure I pasted my connection string correctly. Have that here. Not sure why that didn't work. I'm sorry. Nothing like debugging live on the air. Just going to drop that real quick just to make sure I've got the correct thing pasted in here. Okay, that looks good. Well, I seem to have botched up my environment variables at some point. So real quick, I'm going to provision a new connection string here and see if I can get that going. Again, I apologize for the unforeseen technical difficulties. Try and get this going back again, but if I can't, I will quickly wrap up and give the stage to someone who does not have technical difficulties. Hopefully Chance and Alex. Okay, so I've reprovisioned. I'm redeploying my preview. And just to clarify one more time, the Prisma data proxy is a layer that sits in between your serverless backend and your traditional database that solves the connection limit problem for you, like I demonstrated earlier with our load test. When you hit a serverless backend that's connecting to something like a Postgres without any means of connection pooling mitigation, you're going to hit a lot of errors. And that's really the core of why we made the Prisma Data Proxy, is to make that process easier of fixing that error for the average developer, someone like me. A very average developer. I think I've deployed the wrong site here. That looks better. Okay, so this was my simple web application here. And you see we have all these duplicate nodes created. And that's from my load test earlier, where I was trying to hit our unproxied application. You saw we do get some success with getting nodes through, but you saw we had about a 30 to 40% of our writes failing because of a connection limit issue. Now, as this deploys and gets uploaded, we'll be able to swap our load test over to the proxied version, and we shouldn't have an issue. All right, that looks better. I apologize for the rough patch there. But now this is a new branch of my application that does have the proxy set up. I've used my new proxy connection string, and I'm going to run a load test against this now. A load test against my new application, and I'm going to make sure I don't expose any environment variables. I apologize for flipping my screen on and off. I just want to make sure I'm protected from exposing anything on the on stream. Get that back up. All right, so now I'm running the same load test. Again, about 50 or so virtual users hitting my back end continuously for about 5 or 10 seconds. Again, this is using my new preview deployment that's using the Prisma Data Proxy to buffer those connections and hopefully fix our connection pooling issue. So before we had about 30 or 40% failed requests. We're going to take a look at how that is now. Okay, so right here is that same metric, and we have 0% failed, or in other words, 100% completed. So I apologize for the rough experience there with the deploying the wrong branch, but if you do everything correctly, you can set up a data proxy in between your serverless backend and your relational database simply by swapping out the connection string and generating your Prisma client to use the data proxy. And you really don't have to worry about the connection pooling issue anymore. I just want to emphasize, like, getting this set up as opposed to setting up horizontal scaling with your AWS database and provisioning the right R3 dot extra large, whatever Postgres instance, worrying about connection pooling, etc. The goal here is to have minimal config for maximum value. And again, as someone that's not a DevOps guy, isn't a big fan of the AWS console, this is really a great way to go. Okay, so it was a little choppy, but I got my load test done. I have my web app deployed, excuse me. And I've showed a little bit about why the data proxy is valuable. If you want to get started with the data proxy, please go to cloud.prisma.io. It's free to get started and get deployed and help fix that the connection pooling problem or the connection management problem for your serverless backends. Okay, before I break anything else, let's move on to our next speaker. Our next speaker is Chance Strickland. We're really excited to have Chance here. He is a software engineer on the Remix team. He loves traveling, surfing, and helping developers like me build better websites. And Chance, I could have used you a few minutes ago as I was running into my own issues. But we are so happy to have you. Chance, how you doing today?
Hey, doing great. There's nothing like doing it live and running into all of the fun experiences that come with that, right?
That's right. Yeah. It would have helped if I was clicking the right button, deploying the right version of the site, but we got through it. Chance, we're really excited to have you today. I must say the mustache looks great. It comes through great on the stream. I'm a big fan. Chance, tell me, how long have you been with the Remix folks now?
Yeah, it's an interesting question because I joined the Remix folks a couple of different times actually before Remix was a thing, and I worked with Ryan and Michael a couple years back on the Reach UI library. If you're familiar, it's a library of accessible React components, and we worked on that for a little while under the umbrella of the React Training Company. React Training, as the name implies, is a training company for teaching folks how to use React. And I actually shifted from Reach UI to working with the modules team on Radix UI, and then I ended up coming back to React Training as an instructor. So I did work on all of that for a little while, and shortly thereafter, Remix became a thing, and decided to start working on Remix with them pretty much right from the get-go. So as soon as it became an actual product, I jumped over, started working with that team, and it's been a lot of fun.
Well, that's great, and we're glad that you are. I've really enjoyed your work, keeping up with your work a little bit as you've gone from the Reach UI. So I think Reach UI is an awesome project. Everyone should go check it out if they haven't. But without further ado, let's get you into your talk so you have the most time possible. So if you wouldn't mind sharing your screen, and I'll get you going.
Yeah, let's go ahead and do that. Boom, 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 boom. And I'm going to go entire screen. We're going to see what happens with that.
Yeah. Hopefully you don't.
And I'm going to do like a little split view here.
Cool.
So I think that'll be good. So let's talk about optimistic UI, shall we? So when we create any sort of web app that has to deal with data mutations in a database on a server somewhere, you're going to need to give the user some sort of feedback, right? Like as data is being mutated and changed, it's going off to a server. We send this request off. There's some processing happening. It's going to send us a response, and depending on the connection speed, we may or may not get that response back in a timely manner. And while that's happening, obviously we have to show the user something, right? We can either not show them any sort of pending state. We could potentially give them a loading spinner or something. So we've got this idea of a pending UI where we indicate to the user that something's happening, but it might be taking a little time and they should wait before proceeding to do whatever the next thing they might do is, right? So that's our pending UI. And we also have this concept of an optimistic UI. You might hear my dog over here. She just started growling at the mailman. So apologize if there's any noise there. She starts barking. But anyway, back to the point. There's also our optimistic UI, which just means that we can show the user some sort of response that we think the server is going to return, or that we're pretty confident the server is going to return to us a certain response. So instead of waiting for that to happen, we can just go ahead and update the UI with what we are pretty sure is going to come back anyway. And then we can go ahead and update the UI much faster that way, right? So pending UI is going to be most likely more accurate, but it can be a little slow at times, especially if the user is working with a slow connection. Conversely, if they have a really fast connection, we can run into another problem where we show a pending UI too fast, and then you end up with this janky experience where there's all kinds of stuff happening on the screen way too fast, and it just creates a lot of moving things and just feels funny. And this is where React comes in and says, hey, we've got this suspense thing where we can only show you the next UI if the response takes a certain amount of time to come back, in which case then we'll show our loading spinner. So we sort of defer that, right? So we've got these workarounds. But I'm going to talk about optimistic UI, because optimistic UI can show the user feedback pretty much immediately, which makes the app feel much faster. But oftentimes we avoid implementing our optimistic UI because it's hard, right? Like it's hard just on an implementation level sometimes to get it right, but it's also just fundamentally hard because we don't always know what the server is going to give us, right? Like if we knew ahead of time, we wouldn't need the server in the first place. So and what happens if the response we get back is different from the response that we guessed, right? What happens if the server throws an error, right? We have to deal with that error. What happens if there are race conditions and the responses come back in a slightly different order from the request we initially sent off? So there's a lot of foot guns here, a lot of potential problems, and so it's often easier to avoid it, and we just do what we always do and create these pending UIs. But again, in certain cases, optimistic UI, it can make our apps feel much, much faster and create a better user experience. So I'm going to show you how we could implement something like that in Remix and how these APIs, I think, make it a little nicer. So I've got this app here. I'm going to go ahead and run our dev script. This is a Remix app, obviously. We're going to go ahead and load it up, and it's just a simple task list here. We've got some tasks, and what we want to do is right now I've got a pending UI. So if I start clicking around on various tasks, it's going to go and update my database. And this is all running locally. My database is going to be super snappy, but I've got some artificial blockers so that it takes a little bit of time between updates. So you'll notice if I click one of these tasks to check it off the list, it's going to eventually update. And I'm going to go in real quick and clear something out because I have missed a thing in the interim period. Sorry about that. Ignore what goes behind the curtain. As I was saying, we've got this slower response. So it's going to take a couple seconds or half a second or so before this is actually completed. And in the interim, we sort of fade out to, we have a lower opacity to indicate that this thing is actually loading, and we're not updating it immediately. So it feels a little slow, but once the response comes back, we update our little check mark to indicate that this is complete. It's now green, and we can move about our day. I can also create some new tasks. So explain how great Prisma is with Remix. That's just Prisma is in general, right? Prisma's awesome. So explain how great Prisma is. And see, it took a couple seconds there too, and eventually we got our new task. And in the interim, you may have noticed that we disabled the task field so that we could prevent adding continuous tasks. So this is our pending UI, right? So what if we wanted to set this up as an optimistic UI, optimistic updates for our tasks specifically, so that when I click one of these tasks, it actually updates immediately. And so let's go in and take a look and see what that looks like. So just to sort of walk through our app for a second, we've got our Remix app. If you're familiar with Remix already, you'll know that in every Remix app, we've got our app folder. In our app folder, we've got our routes folder, and that routes folder is exactly what it sounds like. It's our routes. It's the routes for our application. So right now I'm just on localhost 3000, which is my root, my index app. So inside of routes, I've got this index file, and this is our route. This is exactly what we're looking at. And this is our only UI route, right? We'll talk about our task routes here in a few minutes. But right now, we've got everything on this index route, and we've got a few things in the file that we can talk about. We've got this loader. The loader is going to, this is our artificial wait method that's just sort of slowing down the initial request a bit. I actually can get rid of that here. And we are fetching some tasks from our database. We're importing this database helper from this server module, which is just setting up Prisma and connecting to everything. And this is how we're going to interface with our Prisma data calls. So we're fetching some tasks from the server in our loader. The loader is basically responsible for making GET requests to a server, and anything that we return from our loader is going to be available in our route component. Also important to note that the loader is only ever called or used on the server. We code split all of this stuff out. So anything that's in your loader will not be included in your ultimate client bundle. But the actual route component itself, what we see on the screen, is our default export from this route file. So we've got this default export, this component, and this is what we're going to ultimately see, right? We've got these tasks that we've got from this use loader data function. Use loader data is it's what we get from our loader, right? So In the event that we have tasks, we return them. If we have an error of some kind, we don't return anything. So it's just nothing, right? So this is where use loader data comes in handy. And we're just iterating through those tasks, and we've got a few different components that we use to actually render them. So that's just a little quick walkthrough of what you're looking at here in the remix route component. So what I'm really interested in here is our create task component that I've just split out down here for simplicity's sake. So what we want to do is we want to update these tasks pretty much immediately. We don't want to wait on the server to give us a response. We just want to immediately indicate to the user that this task is either complete or not. So one thing that we can look at here is how do we actually indicate our tasks are complete? Well, we've got this is pending state that we determine. We've got a few different things that can tell us whether or not this thing is pending. We've got this clear task state that I'm getting from this this fetchers object, which comes from use fetchers. Now, I'm not going to talk too much about the difference between the use fetcher hook and the use fetchers, but essentially, any route can have multiple requests from a fetcher going off at any given time. A fetcher is essentially an object that represents data that is being sent across the wire, right? And anything that's in a fetcher is happening on that route. So we can request data from any route without navigating to a new route, and that the object responsible for representing that request and all of its various states and any data associated with it is available in a fetcher. And we can have multiple fetchers. So the use fetchers hook lets us deal with any of those fetchers, and we've implemented a fetcher in the in this clear tasks button that is going to delete all of our tasks. So we differentiate a little bit, but the fetcher in our create task component is going to be responsible for managing the request in that specific task. Now that that's all, I hope a little clear what's going on here. We are determining our is pending state based on the state of each of these fetchers, right? We want to show a pending UI in the event that either we're clearing the tasks or we are updating the individual tasks, right? That's responsible for determining this is pending state. And the actual state of our task, right? The is it complete or is it not complete? We see that we've got, or actually that's the wrong component here. Let me jump to the correct component, which is our actual task component. So the create task, I apologize, is actually this input down here, but it's very similar to our actual task component. It has all the same setup for dealing with multiple fetchers. But what's really different here is that the actual state of our completed state, which is slightly different, this actually comes from our object in our database instead. We've got this completed object. We can even take a look at our schema here. This is our Prisma schema that we have a model that represents a task. And the task is going to tell us whether or not it's completed, right? That comes from the server. But what we need here is we don't want this always to come from the server. We want to determine whether or not this component or this task is complete based on the event that the user just initiated, right? We want to optimistically update this state. So to implement this in Remix, it's actually relatively simple. We just need to change the source of truth for our completion state. We need to say, instead of getting this from the database in all cases, we need to determine whether or not we're currently in a pending state. And if we're in a pending state, we want to optimistically reflect the completed or not completed state based on that pending state. So how can we do that? It's actually, I think, quite simple here. We've got this is pending indicator here that is just derived from our various fetcher states. So I'm just going to say, if we're pending, I actually want to show the opposite of what's coming from the database, right? This is just a Boolean state. Our completed is always a Boolean. So if it's currently completed, we want to flip it on its head. If it's currently incomplete, we want to flip it on its head, just return the opposite. And once is pending is false, right? Once our fetcher is done doing what it's doing. And in fact, I'm actually going to change this a bit because we don't want to flip this if our clear task state is loading or submitting. We actually only care about the state of this specific fetcher. So instead of using the is pending state, I'm actually going to do this, right? And I'm going to, just for clarity's sake, let's make this two separate variables. I'm going to say is clearing tasks, and I'm just going to look for those specific pieces of data from that specific fetcher, and I'm going to say is updating task, right? And we will just rename a couple of things here. And so we now have two separate variables. We can be a little bit more clear about our intention. So if we're updating this specific task, go ahead and show the inverse of that, right? We are now optimistically updating, because once we get that data back, the fetcher state, the state that we get directly from our fetcher, right? Fetcher.state is going to, fetcher.state can either be submitting, loading, or idle, right? We are looking for that idle state, which means no request is currently incoming. So once that state is set back to idle, this updating task will be resolved to false, and we will have the actual response from our server at that time, right? So let's save that and see what we get. That's nice. So you notice the checkbox actually immediately responds. We are still showing a pending UI here in the sense that the task is grayed out behind, and let's go ahead and change that. That's just happening because of some data attributes I've put on the task itself. So instead, so this data pending thing is what I'm looking at. So if we're updating the task, we want to show the pending UI. In this case, I only want to show the pending UI if we're clearing tasks. So I'm just going to change those attributes, and the styles should change accordingly. Boom. Immediate updates. Feels much snappier. And I could, if I wanted to, go and start implementing this in my other fetchers as well. I could say if I wanted to create a new task, tree. Notice our pending UI there is still in place. We could update that as well to make it feel a little faster as well. Same thing with our clearing tasks. If clearing tasks takes a while, we might want to optimistically clear those tasks, but we also might not. So before we get too far, let's talk about optimistic UI as a concept, right? We now sort of know how to implement them in Remix, but should we? Should we? Well, let's think about, again, going back to the pros and cons of an optimistic UI versus the pending UI. The optimistic, or the pending UI rather, is always going to be technically more accurate based on the data as our source of truth. The optimistic UI, as the name implies, is optimistic that our request will succeed. So let's take a look and see what happens if it doesn't, because we don't want a bunch of jank in our application in case something goes wrong. So I'm going to take a look at this complete route. And I mentioned earlier that we had these other routes in this tasks folder. These routes are what are called resource routes. And Alex is going to talk more about resource routes and some of the cool things you can do with them. But essentially what a resource route is it's only going to expose either an action or a loader. It's only going to handle get or post requests. It's not going to be responsible for rendering a UI. So it's going to return some sort of resource, a response we consider a resource. And in this case, I'm using it to essentially create a nice little REST API. I'm sending a request to this actions endpoint, and based on that request, I'm going to return some data. So when I submit that fetcher form, it hits this endpoint. We're artificially taking a little bit of time to complete the task so that I could illustrate the point with optimistic UI. We're going to go through and process the data from this request, and eventually we're going to return some data based on the response. Okay. So what happens if this throws some sort of an error? Let's simulate that. Let's go ahead and set up a try catch here. I want to make sure that I'm handling my errors. If you don't handle your errors in your loaders or your actions, you're going to end up in your error boundary. I'm not talking about error boundaries today, but I want to handle this directly on the server instead of letting my app UI take the brunt of the error. So in the event that I have some sort of error, I'm going to catch it, and I'm just going to return a response. It's going to be a JSON response. It comes from this Remix helper. I'm going to, let's see, I'm returning a task. I don't have a task. So I'm just going to return null, but I'm going to say, I'm just basically returning the same form error that I did here. I want my data to be consistent in the app. And this will be a 500 response. So I'm going to use the status code there. And let's just throw an error. Let's say let's just randomly throw. So we'll say if math.random is greater than, let's say 0.3. So just, we'll throw here. And we'll say it's a coin toss. We'll do 0.5. So sweet. We'll just blow the app up in like 50% of the cases, right? So now when I hit this endpoint, we expect that in some cases we're going to get some sort of error. So what happens? We're going to optimistically update this UI, but then we're going to have an error, right? So I'm going to check off some stuff. See, what do we do wrong? So I've got this, so I've got the error here. Oh, I didn't put that in my try catch, did I? This is where an error boundary would come in really handy, but I don't want an error boundary. I want to deal with it on the server. All right, this should be better. Okay, so we got an error, right? What happened? The UI updated immediately, but once the response came back, we fell back to our old state. So we wanted to show some sort of UI, something in our UI to indicate that this request failed, right? So we have this error message here. You could argue that it's not a very good one. We could improve that a bit, but it tells the user that something went wrong. Instead of just flashing the checkbox, we've actually responded. We've sent something helpful in our response. Something went wrong. And in our UI, we actually can handle it. I didn't mean to do that. Let's fix that now. Uh-oh, I goofed up and messed up my full screen experience. So I'm gonna fix that real quick. All right, so anyway, no more fun split screen experience, but that's okay. We can still see what's going on. So we've returned this response and we now have it in the form error that we get from our fetcher data as well, right? So we've handled this a little gracefully, and Remix gives us nice APIs via this fetcher object to interface with both the actual response as well as the response, the request state, as well as any errors that we happen to return in that response. So again, do we want to go in and actually implement this optimistic UI approach everywhere? Do we want to go in and change our creator field to use an let's just try and see if we can get this to pass. Our math.random seems to be throwing much more than 50% of the time. All right, there we go. Cleared up. That response worked out. Do we want to implement this everywhere? I'm not sure. Do we even really want to implement the task? Like, we got a bunch of errors there. I'd argue that if you are dealing with a lot of errors from your server, you probably have some other issues you need to work out. If you're having a lot of errors from your server, you might have some validation problems. You might want to take a look at that. But the question, should I implement optimistic UI throughout this application, really boils down to, can I confidently guess what response the server is going to give to me? In the case of a checkbox, I think so. It's a Boolean response one way or the other. It's really easy to validate those requests. So you can be pretty confident that you're either going to get a true or a false back depending on the previous state of that object, right? So in this case, I have no issues with an optimistic UI, and actually I think optimistic UI is a much nicer experience. In the event that you have some sort of a text input, let's go ahead and remove that random error so we don't have to look at all that stuff anymore. Now, in the case of a text input, it becomes a little more nuanced. Now, you always want to validate your inputs on the server. However, with a text input, what if the user is trying to inject a malicious script here, right? So you want to be sure that we are validating and sanitizing the user's input. And we're going to do all of that on the server because it's probably going to introduce a bunch of expensive operations, and it's just safer to handle it on the server anyway. If you are doing a lot of heavy validation, you probably don't want to replicate all of that validation on the server and on the client. If you have relatively simple validation and you're not drastically changing the data that's coming back from the server, you could argue that maybe I might implement an optimistic UI for this input field as well. That's entirely up to you, but that's sort of the way that I look at assessing these sort of experiences. The same thing with our clear all tasks button. We might not want to just immediately wipe out all the tasks because it would create a lot of jank, right? Optimistic UI can create a lot of jank if the response returns an error. In the event that a task returns an error, it's very little jank because we just show an error message right there in line. We could even move the error message to the right of the task itself, and it would actually create even less of a janky experience because we don't have to move the tasks up and down. So these are the sort of considerations I would think through if I were implementing this in my own application. But I think optimistic UI is a really nice experience in a lot of cases, and we often just don't implement it because it's hard. Remix gives us a lot of tools to make it a lot easier, to simplify it via nice APIs, and to create a faster, much more pleasant experience for our users. And with that, I'll turn it over to Alex.
All right, thanks so much, Chance. We really appreciate your time and in preparation, chatting about optimistic UI a bit. I can definitely relate to not wanting to implement it because it's hard. I don't want to deal with the issues, but I really appreciate the thought behind the abstractions that Remix provides you, as well as some of the tools it gives you to make it a lot easier. So that was a great explanation. I appreciate it. We have a really important question in the chat asking if we coordinated shirts today, and we did. We did not, but it worked out well. You know, what can you say?
You could say that I cheated because as you remember, I had to rush off before we started because I realized I had rolled out of bed this morning and hadn't showered. So I saw you ahead of time, and maybe that was in the back of my mind when I chose this shirt.
It was subconscious. It was subconscious. Yeah. Well, maybe next time I can have a mustache, and then we can really match. Anyways, thanks so much, Chance. I really appreciate it. I'm going to drop you and bring Alex aboard, but thanks so much for your time.
Happy to.
All right, so that was great. We really appreciate Chance's time. Just another quick reminder about the raffle. Make sure you get your name in the raffle. The link should be in the YouTube chat, and we'll be drawing those 5 winners right after Alex's chat. Great. Okay, so yeah, let's bring Alex aboard. Alex Anderson is teaching about TypeScript at UI.dev, and he's building a spaceship game at Thorium Sim. Let's bring Alex aboard. Alex, tell us about your spaceship experiments.
Well, why don't you pull up my screen really quick and I will show you.
Yes, let's do it.
Yeah, so I'm working on a spaceship video game in browser built with React and tools like 3JS and that sort of thing. This website, thoriumsim.com, it's actually built using Prisma. So that's my single Prisma shout out for the entire presentation.
Love it.
But the idea is it's like a spaceship game where you're flying around in a spaceship, except you have a bunch of friends come with you. So you have somebody who's the captain giving the orders, the navigation, who flies the ship, weapons, who defends the ship, an engineer who fixes everything, that sort of thing. Everybody has their own position, their own role, trying to accomplish a mission together. So it's open source, and we're looking for contributors. So if you're interested in checking it out, take a look at the GitHub, join us on Discord, all that stuff.
That is very cool. I can say I would not want to be in the captain's chair, at least not to start out. We all saw how I tried sharing my screen earlier. So running a spaceship maybe is a little bit down the road. But Alex, we really appreciate your time. Without further ado, I'll give you control here of the floor. And you're going to tell us about Remix resource routes. Thanks, Alex.
Sure thing. And I'll just give another shout out to UI.dev. This is what I do for my day job. I'm teaching TypeScript. And if you want to learn more about TypeScript or React, or if you know somebody who wants to learn those things, send them our way. Also, sign up for bytes.dev. It is an incredibly relevant and incredibly irreverent newsletter that we drop in your inbox every week talking about JavaScript stuff. So we'd love to slide into your inbox every week if you don't mind. With that, we're talking about resource routes. Chance touched on them a little bit. They're basically a route in Remix that doesn't give you any UI. Instead, it gives you whatever you want. Instead of returning HTML, it returns anything. It's basically like an express route that you can return whatever you want with. So we're doing some weird stuff with them today. Chance demonstrated that you can use it to create a REST API using Git and Post. We're going to be doing other things than that, and these are the things we're going to be looking at. So I've got my code over here, which we'll be looking at how each of these things is implemented, but we'll start off at the top with the webhook API. Suppose you're building a little automation to make it so that when different labels are added to your GitHub issues, they are automatically rearranged in the GitHub project's beta. So here I have JSON payload for an issue that's had something happen to it. It looks like it was closed. And we're going to use the GitHub or the Remix resource route to make it actually make those adjustments. So we'll go into app and then routes, and then I have it in the webhooks github.ts file. And we've got a whole bunch of things going on here. I've got GraphQL queries for each of the GitHub project's beta queries we need to make. So this one gets data from the project. This one adds a issue to a project. We can change the status. We can delete items, that sort of thing. And down here is where the magic actually happens. I'm using a remix action because the way that the GitHub API works or webhooks works is it sends a HTTP post message to an endpoint that you specify. So if I wanted to do that, let's see here, if I'm adding a webhook to this repository, I can say http://. This isn't going to work properly because it can't send messages to my localhost, but I would say localhost 3000 / and then the route that I want to use is webhooks/GitHub. So I'd say webhooks/GitHub. And I can choose the content type, either XWWW form URL encoded or application JSON. That's the one I'm going to use. And like it says up here, it's going to send a post request to this URL using the content type that I specify. So here I use action because I want to, because I'm receiving a post. If I was receiving a GET, I would use a loader. And that's just the way that Remix routes work. I parse the body into JSON. I get some data using those GraphQL queries that I had up above. I define some functions for executing those queries. And then down here is where we actually deal with the body itself. So I have two different things. Sorry, it looks like three different things that I can do based on whether it's an issue we're dealing with, a pull request with a review, or just a regular pull request. And I'm just switching based on the action of the payload. So over here, see that the payload action is closed. So I can scroll down and see here is the closed action. We're going to make sure that it's been added to the project. We're going to get some information out of the issue that we're adding. And then we're going to change the status. If the issue was pre-approved, if it was supposed to be included in the project, then we're just going to change its status to done. And if it was not in the project, if it was not approved, then we're just going to remove it from the project altogether. And that's it. And I have different actions for all of the different actions that I want to have happen. So if an issue is opened, or if an issue is reopened, or if it's labeled, or all of that stuff. And then at the very end, I have this return JSON. This JSON comes from, let me see. It comes directly from Remix. So I'm returning just a regular JSON payload. I say that success true is the payload itself. And then I set the status and the headers to make sure that GitHub is able to parse it properly. And then in the event of an error, I say success false, since that's what GitHub's webhook API is expecting if there is a problem. And then GitHub can tell me that there was a problem with it. And so I can take this JSON payload. We can come over here and post it. So I'll say webhooks/GitHub as the URL. And for the body, I'm going to do a raw JSON request, paste in that body there. I'll click send. It's going to do its thing, and it's going to say success false because something happened. It blew up for some reason. It looks like we can see it's not able to actually read some properties because I haven't set up environment variables in order for it to be able to access the GitHub repository. But you can see, even though it failed with glory, and actually told us that, like, we can see that this is actually behaving the way it's supposed to. It returned a JSON payload after attempting to do something. So that is how you can use Remix resource routes for webhook APIs. Specifically the GitHub API, but this works with any webhook API. You just have to add the webhook pointing to that specific route that you want, and then it'll send the messages there. You can add a secret if you want to make sure that it actually is coming from GitHub, whatever you want, and it'll just work. Let's see. The second thing we want to do is dynamically generated CSS. And this is one where you can have a little bit of fun with it. The idea is you can have CSS that lives inside of your public folder, and that's just going to be available. Like most frameworks, like Next or Gatsby, the public folder is just provided to you verbatim. So we've got the favicon here, which is just going to render on any page. You can access it by going to /favicon.ico, and it'll just work. And I can put CSS files in there, and they'll just work too. But what if I wanted to make it so that the CSS was dynamically generated based on something? Data in the database, in my lovely Prisma database, a cookie which the user sends, URL parameters, something. I want to adjust the CSS magically based on some data. Today, I'm going to keep it simple. We're just going to have a random style. So here is the actual HTML that I'm returning. It's an H1 with the class name of random color, and I'm accessing it. I'm pulling in the CSS using the links API, which is part of Remix. The way that you add CSS to a page is by exporting a function called links that returns an array of the link tags. So the tags that are like link rel equals whatever. And Remix is going to render these in the head of the page, and it's going to dynamically swap them out whenever I change pages. When I say pages, I should be saying routes. That's technically more accurate, but you know what I mean. Let's see. So I have rel style sheet, and href is /randomstyle.css, and that is coming from this file right here that has a very weird name, randomstyle square bracket .css close square bracket .ts. This is actually another Remix thing, which lets me change or specify the extension of the route. Okay, so you can use Remix resource routes to return anything like JavaScript, like a PDF, and you might want to make it so that when you access that particular route and it returns that particular thing, it has the .pdf or .js or whatever extension you want. This is how Remix lets you do that. So this is still a TypeScript file because it does end in .ts, but when I go to access it on the browser, in fact, let's do that right now. I'll go to /randomstyle, yeah, .css, and it gives me a CSS file. And we can see every time I click the refresh button, it gives me a random hue in HSL. So if I go to the actual page, every time I refresh this page, it's going to give me a random color because it's loading that dynamically generated CSS. It's dynamically generating the CSS file every single time. The way that it's doing that is just by interpolating the CSS string, and then I return it using a response object. This is actually part of the web API. This is how Remix does responses. The JSON helper that I was using before is just a wrapper around response that automatically adds in the application JSON content type. But since I want to use a text CSS content type, I'm doing a raw response here. So this is the text of the response. This is the headers with the content type of text CSS. And that's how my browser knows that it's actually loading the CSS file. I could put whatever I want in here. I could load data from the database and use that to determine the random color. Or I could make it so that the user's theme is stored in a cookie. I pull the theme out of the cookie, and then I dynamically generate the CSS for that user based on the theme that they want from the values in their cookie. Or it could be that they want to specify specific colors for specific things. I want the text to be this, and I want the body to be this, and I want whatever. You can do that, whatever you want, and it just packages it into a nice CSS file dynamically generated for each user. You could cache it in a Redis database. You could do whatever. It's your application. You are the programmer. The power is in your hands. And Remix just happens to make it really easy. So that's our random style. Let's see. If anybody has any questions, feel free to pop them in the chat. I will pull them out of the chat when I get to breaking points. But we are going to move on and take a look at cached CSS and JS. Okay. Now, I actually want to go to the Remix documentation for just a second and see what they have to say about CSS and JS. I know that for a time they were like, you shouldn't use CSS and JS because reasons. But now in the documentation, it specifically says you can absolutely use CSS and JS libraries like styled components. Some of them are going to require a double render because you have to first render the page with all of the routes, and then you have to extract the styles from that page and then render again with the styles applied. But they say it's unlikely this will affect your performance. React is pretty fast, and this is true. I've never had a problem with the double render because unless your page is absolutely bonkers with thousands of components, it's probably going to render really quick. That being said, it might be possible. There might be situations where you want to make it so that your CSS and JS styles are cached so that you don't have to do the double render every single time. You only have to do it once based on the contents of the page. That's what I'm doing here. I'm rendering this with CSS and JS. And we can inspect it and see that it has some Tailwind styles, but I'm actually not loading Tailwind in this app. I'm using a CSS and JS library called Twind. Let's see. I want CSS and JS right here. Okay. And I'm just loading the TW utility from Twind, and I am using it with a template literal tag right here to choose which Tailwind styles I want. And then it is automatically going to generate the styles with the classes for whatever Tailwind styles I put in here. Instead of having to set up Tailwind with the purge options and stuff. It's just going to do it itself. Although the Tailwind JIT mode is really awesome. So definitely check that out in Tailwind 3. So that's how I'm getting the styles. How am I caching it though? Well, you can see here, I've got this styles.ts file, which is another resource route. This is what's actually generating the styles. We can see that I'm pulling out the URL. I'm getting a hash from the search params. And if there's not a hash, then it's going to throw an error, but that hasn't happened yet, so no worries. And if it did throw this error, I could catch it with a lovely error boundary. I'm not going to talk about error boundaries either, but check the docs for those because they're cool. And then we're going to use this get styles by hash utility that's coming from the style context utility. And if there's not a styles in the hash, if there's not a cached style, then it's just going to return a 404. Otherwise, it's going to return my style data that's been cached using the text CSS content type with a very long cache control. And that is that. Well, so the idea here is we're going to be able to go to the CSS and JS /styles with a hash URL search param, and it's going to give us styles for that particular hash. So where do these styles come from, and how do they get hashed in the first place? We'll go into the get styles by hash utility function, and we can see we're actually putting these into global. So that's where our styles are cached, is just in memory. But we could cache them in Redis or some other caching mechanism by the hash, using the hash as a key. And that's how we're getting the styles. How do we generate the styles in the first place? We're using this render with styles function. Okay. We have an edit styles function, which is initializing the styles to begin with, creating our cache, setting up Twind, and creating a virtual sheet, which is the way that Twind does server-side rendering. And then every single time we render our app in entry.server.tx right here. Instead of using the React render function, we're using render with styles, which wraps the React render function down here. This is where we're calling render to string. And this is where we do the double render. We first render to string to get all of the styles for the first time. We use the get style tag properties function, which comes from Twind, to get all of the style tags, the styles themselves, out of that sheet, which Twind has already set up. We're going to remove white space, and then what we do at that point is we hash the styles, and we store the styles by hash, feed the hash to the app, and render it again using this style context provider. And that is what actually renders the styles, puts them into a style sheet that we're accessing with the resource route, and then actually rendering the app so that they're cached. Let's see. And then we have this use styles hook, which is rendering a link component itself using the get path for hash function to get the appropriate link to the resource route, which is rendering the styles. But we use that in our root component right here to actually render the styles, and we render those right here in our head tag. That sounds like a huge rigmarole in order to get CSS and JS caching and working properly. That's why I mentioned at the very beginning that Remix says you can absolutely use CSS and JS libraries. React is fast. It's not going to be a problem. But you can use resource routes to cache your CSS and JS to make it so that you don't have to deal with that double render every single time the page is loaded. It can be just a little bit faster for most of your users otherwise. Okay, let's do something a little bit weirder. I'm just going to close some of these, come back here and come back here. And we're going to do some dynamically generated JavaScript next. And to demonstrate this more fully, we're going to render a Svelte component. Okay, so here I've got this Svelte folder inside of my app folder that has this app.svelte file. And it just has a div with some scoped styles. I don't have any nested components. I don't have any state. I don't have any of that stuff. We're just keeping it simple. But this is going to render this to the page after generating the JavaScript for Svelte. Okay, so let's take a quick look at how that works. We've got, inside of our routes folder, we've got another Svelte file. And in here, I'm using loader because we want this to respond to GET requests. I'm going to use fs read file sync to pull in our Svelte app, and I'm going to compile it using Svelte's SSR configuration option. I'm going to evaluate it using eval, which is dangerous. That's how you know that we're having some fun here. And then I'm going to use component.render in order to render it to actual HTML. From there, I generate a little bit of HTML boilerplate. I put the CSS in a style tag at the top. I put the output HTML inside of the body. And then we're going to render it using the text HTML content type. So this isn't actually dynamically generating a JavaScript file. It's creating a JavaScript file, executing it, and turning it into HTML all in this loader. If I wanted to add some lovely Svelte dynamism with state and other components and stuff, I absolutely could do that. Generate the JavaScript here in a loader and load it, and that would be positively bonkers. But you can do that. It's allowed. So let's see. Ta-da! This is rendered with Svelte. Hey, Austin. Hopefully you don't do this. This is like possible. It might not be a bad idea, but it might be a terrible idea. It depends on what you're doing. I can absolutely see some situations, though, where this might be what you want to do. You actually legitimately want to do something like this. For example, if you are loading in some third-party libraries and you want to embed the API token keys for your third-party libraries inside of the JavaScript file, so you don't have to just keep those in global environment variables. You could do that with this kind of thing where you're returning, instead of text HTML, application JavaScript, and have a dynamically generated JavaScript file. Suppose you embed Remix into an Electron app, and you want to make it so that your Electron app loads plugins from the file system. You could do that using a resource route with loaders that is able to pull in all of the data that you need, render it properly, and return it to the Electron app using a Remix API resource route, and do it that way. You could load ESBuild into a loader and use ESBuild to bundle these plugins, and you can do it. And like, the concept itself is absolutely bananas, but the actually doing it is very, very straightforward. Remix makes it really easy. The resource routes allow you to return whatever you want, and it just works. Let's do, for my final trick, we are going to dynamically render some video. We're going to do this using a library called Remotion, which lets you pass in a React component that uses some special hooks to hook into a frame rate and a current frame. And you can use that to animate all kinds of stuff. So I'm going to come in here and do this video on demand. Ooh. Type in my GitHub username and click Create Video. And you can see down here it's loading. I actually want to pull open the Network tab as we do this, and we'll watch what happens. Let me see. I want to do that. So it generates this video. I'm going to replay it. It pulls up. It says, "Hi, me. You have 119 public repos." Okay, let's do another one. I'll do UI.dev, and we'll watch the Network tab, and we can see it's pulling it here. Let me pull that up, and we'll look at the timing for this. And let me actually make that a little bit bigger. So we can see what it does is it waits for 3 seconds with this time to first byte, and then it downloads it. And during those 3.79 seconds, it's actually generating the video on the server and then providing that, streaming it, passing it to the browser on demand. Just for kicks, we'll do one more Prisma, and loading, and there it is. "Hi, Prisma, you have 70 public repos. Woo, you're so cool." So let's take a look at how that works. That's happening in the, well, first we have the video route, which is a normal route. We're returning we're exporting a default function that's a React component. Right down here, we're using the form action API in Remix, which lets you call an action, which is a way of calling a post request, basically. So we have this form method post, and we're passing in the GitHub username. We have a button, which is a submit. It's going to submit and do stuff. And it's being submitted to, well, that's weird. Where is it being submitted to? Up here. Hey, it's being submitted to the same file where we have our action up here, which is responding to that post. We're pulling out the GitHub username. We have a little cache just to make it so we don't have to hit the GitHub API so often, so we don't hit in API rate limits. Make sure that it's a valid username, and then we return the username. Awesome. And then down here is where we're actually, so we return the username from this action. So when we hit the submit button, it fetches from the GitHub API, makes sure that it's a valid username, and then returns that username. And that's going to be provided in this action data with the use action data hook from Remix. So down here in the action data, we check to make sure that there is a username in the action data. And then we're passing in this source to the video element with /API/video/ and then the username. That is going to go to this resource route right here, API.video. The dots turn into slashes in the URL. That makes it so we don't have to nest folders forever. So we have API/video/ and then name is the username. It's a URL parameter. This right here is going to get a little bit hairy, but bear with me. we're going to do another check to make sure that the user is correct. We're going to get that data from GitHub, but that data has already been cached if it's coming from here, because the cache is being shared. Yeah, we've got this GitHub cache. So we're automatically putting that in to the cache. No, we're not. That's silly. It should be put into the cache when we make the request here, because we're making the request twice. Whatever. I'm a silly programmer. And then we're pulling out the video, the user data from GitHub with the avatar, the login, and the public repos. From there, we're going to call this bundle function. The bundle function is coming from Remotion. And we also have a couple of utilities from the Remotion renderer. What bundle does is it takes a Remotion React component file, in this case, app/video.tsx, which we'll look at in just a second. And it's going to bundle it using Webpack. So we've already got Webpack being loaded in here. That's what Remotion uses. We're going to get the compositions that were created as part of this bundling process. We're going to create a temporary directory to store some Remotion files that it uses. The way that Remotion works is it uses a headless browser like Puppeteer in order to take screenshots at every single one of the frames. So it renders the frame, takes a screenshot, then goes to the next frame, renders the frame, takes a screenshot, goes on. And then it's going to render all of those frames doing that. It's going to stitch all of the frames together into a video. And then it's going to output it to a file. So from there, I have the final output that's coming from my stitch frames to video function. I turn that into a FS read stream. And then from there, I can just return the read stream as a response with the appropriate content type, content length, and cache control properties. And it's going to return it as a actual video. It's going to stream that video that was just generated that's currently in the file system. It's going to stream it from the file system to the person who's requesting it. Really quick, we're going to take a look at the video just for fun. That's in the video.tsx file here. The way that Remotion works is you register the root, and then you load in the component that you want to render. So that's coming from component/remotion/video. We've got this composition file where I'm passing in the GitHub demo component. Let's see. That's not what I want. This composition is coming from Remotion. I'm rendering the GitHub demo. And then I say how long I want it to be in frames, the frames per second, and the size. So let's go to the GitHub demo component. Right here is the data that I passed into this component when I rendered it, when I created it, which includes the username and the profile picture and all of that stuff. Remotion has a bunch of tools like measure spring and interpolate and stuff that make it a little easy to do some animation. So that's what I'm doing to generate the movements and the opacity and stuff. But I'm just rendering this stuff. I've got hi data.login. I've got the public repos here. I'm rendering the image here, and Remotion just takes care of it for me using the frames right here to I get the current frame, put it into the spring to get the progress, and then it renders everything properly. So that is that. That's how we're able to render these lovely videos. I do want to give a shout out. This video demonstration was originally demonstrated by this person here, L. Gastler, who first demonstrated how to do this properly. One important thing to note is this is only going to work on an actual hardware server. It's not going to work serverless because of the way that it operates and the dependencies that it needs and that sort of thing. So just running it on an actual node server works a little bit better. So that is all I have to talk about now. Hector in the chat has a question. He says, hello, Alex, nice talk. Regarding remix architecture, is there any way to split backend responses and front-end ones? And the answer is yes, I guess. What I'm talking about right now is resource routes. This is a little bit lower level than the normal routes that Remix expects you to return. Remix operates on a server-side rendered type architecture where every single route is going to be server-side rendered. And it also is going to, well, If you load JavaScript on the page for that particular route, it's also going to load up a client-side route so that when you navigate around, it has some nice client-side transition stuff that we're all used to with React single-page apps. And that's all taken care of for you if you just use Remix the way that it is. So there is always going to be a back-end server-side generated component to it and a front-end client component to it. And those two things work together. That's why Remix is so great. Everything that I've demonstrated today with Remix resource routes happens on the back end. There isn't any JavaScript running in the front end in the resource routes themselves, because the resource routes respond to an HTTP request. And that's one way that you can separate your backend from your front end. If you just wanted to render HTML, you could use a resource route like I did for the Svelte demo, where I just generated the HTML and then returned it. Another option is to conditionally load your script tag. So here I have a script tag in my root component, but I could make it so that the script tag only renders on specific pages, on specific routes, and the routes that need to have JavaScript. And then on all of the other pages, I just don't render it, and it just gives me HTML, completely server rendered, no client-side stuff. On the flip side, if I wanted to make it so that some content only renders on the client, I could create a component that is able to detect whether it is in the server environment or a client environment and conditionally render in that case. So that component would look like client only. And I would say if window or type of, I've got GitHub Copilot, which is really awesome, by the way. You should definitely sign up if you haven't already and get on the wait list because it takes a while to get it. So if window is undefined, that means we're in a server environment. Otherwise, we can actually return whatever it is we want to return. So we'll grab some children here from props, and children is a type React node. Yep, that's the type of that. And then I can just return the children in that case. Then when I actually go to render, let's see, suppose I only want to render my head tag. I don't even want to render my children in a server-side rendered setup. I could say client only like this. And this apparently it doesn't like this for some reason. So I'm just going to wrap this in a React fragment, and now it's happy. Okay. So now this client only component is going to make it so that if I server-side render this, it's not going to render anything inside of this component, which means my children aren't going to render. It's just my head tag that's going to get rendered and the scripts and all that stuff. And then once it hydrates on the page, once my JavaScript actually loads up, it's going to run a React render at that point, and then it's going to render all of the content. This obviously is a bad idea. Well, I shouldn't say it's obviously a bad idea. I think it's a bad idea. If you might as well take advantage of the server rendering that Remix is giving you, but it's an option. And there are some situations where you do want to not render clients or components in the server. You just want to render them in the server. Same thing with not executing client-side JavaScript, just executing server-side rendering and just getting back HTML. Hopefully, Hector, that answers your question. That's all I have to say. I think I am done. So thank you very much, everyone, for having me.
Alex, thank you so much. That was a lot of fun. I'm a big fan of seeing what kind of mad science we can get up to with these new tools and kind of stretching them. And resource routes seems like a great way to do that. So thanks so much for your time and your preparation.
Super. Thank you, Austin. It's been a pleasure.
Thanks. Everyone, go follow Alex and Chance on Twitter. Chance is at Chance the Dev, Alex at ralex1993. With that, we have finished up the talk portion, but don't worry, I didn't forget about our raffle. Again, 5 tickets going out for Node Congress, which is happening just in a few days. And those winners are these 5 lucky folks here. So if you see your name on the screen, you should be getting an email with your ticket. Have a good time at the conference, learn a bunch, and we're happy to do it. So with that, that's the end of our Prisma Meetup Remix Edition. Thanks so much to Chance and Alex for their time. We really appreciated it. As usual, we'll chop up the talks and get them posted on YouTube. in due time. But in the meantime, everyone have a great rest of their day, and we'll see you at the next Prisma event. Thanks very much.